if you can do the product rule, then you can do the quotient rule because, well, they're pretty similar. You have one function divided by another. Now, once again, I mentioned this before, that doesn't necessarily mean a number divided by a function. You can rewrite this. I would use the power rule for this. I'm talking about one function with variables divided by another function with variables. That's where we're going to use the quotient rule. And once again, if you remember the product rule, I said the dumb way I remember this is fig-gif. Fig-gif. So that's an important one to have. The way we do the quotient rule is we use fig-gif again. It's the same thing, same order, with a couple changes. Now we're going to put a minus sign in here. And believe it or not, on the bottom, we're just going to take that original denominator, the original second function, and we're going to square it. That is not the derivative of anything. That is the bottom function, the denominator function, squared. And that is our formula for the quotient rule. So now this is like anything else. If you're given a formula, you can follow it. You just use that pattern again and again. But here's a couple examples. So here's the three examples that I want to start with. And the first one is just finding the derivative. So you've got the top function, the bottom function. By the way, there is another way of memorizing this. It is a funny little thing, but it says low d high minus high d low over the square of what's below. So we have the low derivative of the high, low times derivative of the high, minus high d low, high times derivative of the low, over the square of what's below. Some people like that little song. Never my thing, but hey, good luck to you if you like that. Here's what we get with the derivative. Notice we got the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. Are we done yet? No! Let's simplify this out and make it look pretty. Well, that's better, but that's not perfect. Still, combine some like terms there. We got 5, we have minus 10. Why don't we just say 5 minus 10 is that? Okay, well, good enough. I know some of you prefer to have the x squared over here. I do too, but I just got lazy. So then in the second example, it's the same kind of thing. We have another function here. It looks like a quotient rule, but notice what I'm asking for now. It says determine the derivative of g at a particular point. So let's first find the derivative. There we have it. Low d high minus high d low over the square of what's below. Play around with it a little bit. Simplify those bits and bobs and things. Make sure you square both the number and the variable. That's a really good idea. Also, it's probably best to have your algebraic part right in front of your trig. It just makes it clearer to read. But now we get to the last part. We want to find out what is the derivative of g when we actually plug in the value of pi. So, what did you get? Well, hopefully you remember that cosine of pi is -1. Sine of pi is 0. Well, that makes that easier to solve. And so we get our final answer there, except it's not final because I still want you to simplify. Yes, ladies and gentlemen, I hope that is your best answer. So now that brings us to example number 3. Still pretty straightforward. Still, just a nice little quotient rule. See what you can do. Did you get the derivative correct? That's the setup. Did you simplify it correctly? Underrated aspect, but it is important. And now what am I asking for here? When does this graph have a horizontal or vertical tangent? The horizontal line has a slope of 0. What would make a fraction equal to 0? Possibly if the numerator equals 0. So I can tell now. If I just factor that numerator, that'll let me know what makes this equal 0. But what makes a tangent line vertical?